Hey Blake, I've got your Unit 1 test review here. So there's a lot of information. This is everything you've done so far since we started school because you're preparing for your first big unit test. So the first question says, what is the additive inverse of the expression below where A and B are real numbers? So the additive inverse is you're basically changing the signs. So 2a plus b becomes negative 2a. You can say plus negative b, but it's really adding a negative is the same as subtracting. So you can see that here, the additive inverse. The second question says, consider the function represented by the equation x minus y equals 3. What's the equation in function notation with x as the independent variable? When x is independent, which is all the time, we don't usually write them backwards unless we're writing the inverse of a function, but it means we're going to solve for y. You want the dependent variable to be the variable that you solve by. So if we have this equation, x minus y equals 3, and we are going to solve it, we're going to subtract x from both sides first. We're trying to get the y by itself. We're going to bring down a negative y. And we typically put the x term in front, so that's a negative x plus 3. That 3 is positive. That subtraction sign that goes with the x. But now I have a negative 1 in front of this y, and I got to get rid of that. So I have to divide everything by negative 1, which is going to change all my signs. So now I get y, a positive y. Negative x over negative 1, that just makes x positive. It's kind of like having a negative 1 divided by a negative 1. That's a positive 1. And then we have 3 over negative 1 or minus 3. Remember that negative numbers, subtraction signs, it's kind of interchangeable. So when I say 3 over negative 1, I'm going to write minus 3. And then with function notation, we change that y to an f of x. A function in terms of x, we get x minus 3. Looks like you might have solved it for x. So when it says the independent variable, whatever the independent variable is, you're solving it for the other one. So I think you solved it for x when you should have solved it for y. Question 12, the function f of x is shown on the graph. If f of x is 0, what is x? So we're looking for all of the places where the graph touches the x-axis. You can see that happens at negative 2, positive 1, and 3. All of the values where the graph touches the x-axis. Okay, sorry, I kind of got interrupted there. A former classmate of mine from 23 years ago in high school happened to be in our building visiting, so I said hi to him really quick. So again, on this one, it is where does the graph cross the x-axis? So when is the y value 0? And it's 0 at negative 2, 1, and 3. Which number is rational? So rational numbers, whole numbers, including 0, both positive and negative. So all positive and negative whole numbers, and then any number that can be written like a fraction. Irrational numbers are decimals that go on forever but do not repeat. And so the dot, dot, dot back here indicates that this kind of goes on and on and on. So that's not rational. Pi is not rational. We know that pi is a decimal that doesn't end and doesn't repeat. Also, numbers that are not perfect squares. So let's talk about some perfect squares. The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. But any square roots that are not perfect squares, those are going to be also irrational. So the reason why this number is rational, first remember it does include negatives and positives, and I can write this as an improper fraction. 3 times 2 is 6, 6 plus 1 is 7, negative 7 over 2, so there's the fraction making this number the only number that's rational. And then the last question you missed asked you to write this as a fraction in simplest form. So repeating decimals are kind of cool. There's a really fancy way to teach you how to write them as fractions, and then there's the really easy way. You take whatever is repeating and you put it over 9. So this would be 2 4/9. Now, if you have multiple digits that repeat, like different digits that repeat, for example, let's say it was 2.41 and the 4-1 repeated, so 2.41414141, right, like this. Because you have two different digits that repeat, we would write the repeating portion over 2 9s. So it's kind of cool. But this is a quick trick with a repeating decimal, that however many digits repeat, you write that number over that many 9s. Remember that 1/4 in a decimal is 0.25, so 2 1/4 is 2.25, not 2.4 repeating. Okay, so hopefully that helps clear up some of the ones you missed. This does count as a grade. They put this in like the homework or the assignment grade category, not as a test grade. So it is something that we want you to do well on because, again, it will also help you study for the test. So when you're ready to I think you might get another, I will reset it for you because I'm not sure if you get extra attempts on this or if I just reset it. If you have any other questions, please reach out. Talk to you soon.